Hi, I'm Paul Kilgan from GK Tuition, and in this video I want to talk to you about area, volume and measurement. Now the question that I've chosen to go through here is 2019 Paper 2 question 5. In this question we're given two different circles. The large circle has a radius of 3 centimeters, the small circle has a radius of 2.5 centimeters. The shaded region is a crescent, and the crescent is formed by removing the small circle from the large circle. And in this question we're asked to find the area and the perimeter of the shaded region to 2 decimal places. So you should realise that the shaded region, a crescent, there's no formula for that, it's an obscure shape. So it's impossible for us to directly get the area of the shaded region. But what we can do is get the area of the big circle, subtract the area of the small circle. The area of the big circle minus the area of the small circle would clearly leave me with this shaded region. If you go to your maths tables, the formula for the area of a circle is given as pi r squared. So the area of the big one minus the small one is just pi r squared minus pi r squared. To get the area of the large one, it's pi times 3 squared. To get the area of the small one, it's pi times 2.5 squared. And if you plug all of that into your calculator, this is the value you should get. But it asked me to leave it to 2 decimal places, so your final answer is 8.64 centimeters squared. It's a little bit trickier to find the perimeter. The perimeter of the crescent refers to the edges of the crescent, the entire edge of the crescent. And in this case, the edge of the crescent, imagine if I started here, it would be the entire big circle, the entire circumference of the big circle, plus the entire circumference of the small circle. Because in theory, I know the two circles touch each other, but they overlap at for such a small section that it's negligible. In the diagram, it looks like they're overlapping for a good distance, but they're actually not. They're only touching. So that means the edge, it's the entire circumference of the small one plus the entire circumference of the big one would give me all the edges around the crescent. If I wanted to follow all the edges around the crescent, I need to get both circumferences and I need to add them together. So the perimeter is the circumference of the big one plus the circumference of the small one. Again, if you go to your maths tables, my formula is there. The formula for perimeter is 2 pi r. So it's 2 pi r, the circumference of the big one, plus 2 pi r, the circumference of the small one. We substitute in r for the radius of the big one, 3 for the radius of the big one, and 2.5 for the radius of the small one. And if you plug that into your calculator to 2 decimal places, you get 34.56 centimeters. Notice that the last answer was squared because it was an area, but this answer is not squared, it's just centimeters because it's a distance. Perimeter or circumference is just a distance, so we don't square our units. So your final answer there is just 34.56 centimeters. Okay, in the second part of this question, we're given an inverted cone. We're told that the vertical height of the cone is 12 centimeters and that the radius of the cone is 7 centimeters. We're told that water is being poured into this cone at a rate of 0.5 litres per minute. Now, the first thing you need to realise is part of your learning work for area, volume and measurement is that you need to know that 1 litre is the same as 1,000 centimetres cubed. 1 litre is equal to 1,000 centimetres cubed. So that means if you're pouring 0.5 litres per minute, 0.5 litres is equivalent to 500 centimetres cubed. So 500 centimetres cubed of water is being poured into this cone per minute. In order to find out how long it's going to take to fill the cone, we need to first find the volume of the cone in centimetres cubed. In order to get the volume of a cone, you need to go to your maths tables. There's a formula in your maths tables that says the volume of a cone is 1/3 by pi by r squared by h, where r represents the radius and h represents the vertical height. So in this case, I know the radius is 7 centimeters, the height is 12 centimeters. So if I just plug into the formula from my maths tables, I end up working out that the volume of this cone is 196 pi, or in other words, it's 615.75 centimeters cubed. So the volume of the inverted cone is 615.75 centimeters cubed. And water is being poured into the cone at a rate of 500 centimeters cubed per minute. We've been asked to work out how many seconds it will take to fill the cone. So now that we have these two figures, it'll be relatively straightforward for us to finish this one off. So we know the volume of our cone is 615.75, and we're pouring water into the cone at a rate of 500 centimeters cubed per minute. So to work out how many minutes it's going to take to fill the cone, you just divide 500 into the total volume. 500 into 615.75 gives me 1.23. So it would take 1.23 minutes in order to fill this cone. However, they've asked me to leave my answer in seconds. We know that there's 60 seconds in a minute, so to convert from minutes to seconds, you just multiply that value by 60. If you multiply your 1.23 by 60, you get 73.89 seconds. The question asked me to leave it to the nearest second, so clearly in this case I need to round up to 74 seconds. So your final answer for part B here is it would take 74 seconds to fill the cone. So I hope all of that makes sense. If there's anything there you're unsure of or you'd like me to explain differently, just let me know in class or send me an email and I'll explain it differently.